In this lecture, we will consider the UNICE technology, which provides a unified system interface and advanced program functionality, eliminating the need for front-end and most back-end programming. It automates common tasks by services, as well as unique ones, significantly reducing the necessity for manual programming and effort. Let's look at the main concepts of UNICE. The first is the screen. The screen is what the program shows to a user at the moment. In this case, the screen is everything that fills the browser below the URL line. The block is a set of logically related elements. Each screen is composed of blocks. This one contains the tree and the text. The second block includes text on the pages. The third block is a toolbar. GUI elements. They fill blocks. The text element is in this block. Here we have a tree. Here is text again. And here are the buttons. User class. An instance of user class that is associated with each connected user. It contains all interaction functionality that we can redefine or extend in case of necessity. By default, the user has all the necessary methods and properties for successful work. And in the norm, we do not need to extend it and even know it, because UNICE already knows where it is and how to us it. However, with deep customization, a programmer has a full control to redefine the smallest user details, can redefine the methods, the constructor, in order to do something that is necessary for business logic. Service. It is an automatic functionality that can be utilized without programming. It does not require maintenance. And it is already integrated into UNICE system and works with each other without the participation of programmers. Let's take a closer look at UNICE. First, we need to install it on the computer. Python should be already installed. Perform the command pip install UNICE. So UNICE is installed. Then we need to execute these commands in Python. Let's create a project for that. Call it app. Open it in Visual Studio Code. As we see, it is empty. Let's create a start file here. Run p and copy these lines. Run it. Let's see what we get out of it. So we have launched the system. We can see UNICE has created a config file. For our convenience, to think less about what is missing. So, in the config file, we see the port on which the service has been launched. Upload-dir is a folder where UNICE loads upload files. Hot reload is the functionality that provides us instant code transformation to visual representation. What we are typing, we immediately see in the running system. Autotests is what the system itself tests and shows errors in our logic, and recorded by UNICE tests. And finally, app name is the name for displaying in the menu. And we can write the program name at the start function also. It will be the same. Let's call it MayaPay. Restart for changing the system name. And what is on the port? The system does not work normally because we do not have a single screen. This must be fixed. Let's figure it out. So, what is a screen? A screen is a file that should be in the folder screens and should contain these two variables. They have to be defined. Unici supports user interaction even when there is missing information or incorrect programs or data within the system. Let's create the Screens folder. Screens. And let's create the first screen in it. Main pipe. Let's give it a name. The screen name has to be unique among other screen names. We got the main screen. It is empty because obviously we did not define what we need to show. And we need to show blocks. We look at what a block is. As we have already shown, block is part of the screen that contains logically related GUI elements. Let's define the first block. In our program, we will call it block 1. Obviously, the block is not defined because we did not import the Unici variables. To do this, write from Unici. Import all. We defined a block, but we did not connect it to the blocks of the screen. What we had to do. To show the block on the screen, we have to attach the block to the block's variable. Let's do it. Blocks equals block 1. So, we have a block. It is empty. To fill it with something, let's add a button to it. So, we have a button. It works, but does nothing. Let's fix it. Let our button return the information window. When it's pushed, button value. To connect the handler with the button, we just write it after the name of the button. And now, when we press the button, we will get a window. Let's look at the button constructor. The button constructor gets its name first. The second argument is the push handler. And there may also be an icon. This is a shortened form that we used. Add an icon to the button and see how it looks. All icons are the names of the Google Material Design icons. So we have specified an icon. It appeared and works the same way. What an event handler is. Let's look at the documentation. All handlers have the same representation. The first argument is the key element that causes an event. And the second is the event value. A handler returns elements or blocks for updating on the user side. We have to return changed elements in the handler. Let's add a new element here. Let's look at the edit element. Edit is assigned to edit strings and numbers. Let's add an edit. Edit equals edit. Param 1. And the value is 1.5. To make the edit appear on the screen, it needs to be placed in a block. Let's put it after the button. The edit is in the block. We can print there. We can increment it, decrement it. We can attach a change type handler to any key element. The button handler is already known. For the edit handler, we have to care about the element value. Button value is always none. Let's write a handler for the edit. We have to save the value that came from the user in the handler. Because if we define the handler, it is our responsibility to save it. Unity doesn't know whether to save it or not. If we define the handler for some event, it means that the saving of the incoming value is in our responsibility. To save it, we just write a line. Value equals value. We saved the incoming value, and then we can show it on the screen. Return in phone. And we write such a line. Element. Name. Value. Is value. We can attach the handler to the edit. When a user changes the value of the edit, it will work and return the event value. Normally, if we intercept the change of an element, it will be the same. But we have to process something. Since we are just studying elements and don't need to do anything in this case, our action is to show the value of this element. Let's check. 2, 3, 4, or can print directly. The same thing, the same effect. Such a handler. can be connected to absolutely any element. Why? Because it has a universal template and view. Each element has a value, which we should save in the attached handler. We don't save it if it contradicts our business logic. For example, if the value is not allowed in some context, then we can return the error and return the value of this element. Let's see how to do it. Let's assume that the value 4 is not allowed for some reason. In this case, we write, if value is equal to 4. Return error. Invalid value 4. And return the previous value. We indicate that the UNICE should return the current element state to the user. Since the element in this case has an old state without the value modification, then return the previous state. If the condition does not suit, then the handler updates it. Let's check. Increment 2, 3, 4. Invalid value. And look, the previous value 3 returned. We want 4. It returns 3. Why? Because we sent its previous state in the handler. This code is universal, and any elements of any type can be substituted here. It will work. Let's remove the condition. Write just a handler. Universal changed handler. And here, replace for a new handler. This universal handler, which we will use to check what values come to elements. Let's make an edit with an autocomplete handler. When we print in an element, an option list for ending will be calculated and shown. But chose them from the list. For this, we have a function called complete. Complete allows us to form a list and send it as a list of autocompletion. Have to determine complete, which takes an element, the current value of the element, and, taking into account, returns the list of possible values. Let's do this. Edit. Complete equals edit set D. Set the initial value A, B, and further complete equals complete. Complete is the function, which we do not have. Let's write it. Def complete. The first argument takes an edit element. The second is its value and returns an option list. Let's set the list of a B, and a C. To show this edit, add it to the block. So, we've added the list of additions. We can select it. We can print directly. Let's look at some more elements. The switch has a true and false state, and two visual types. In the form of a switch and a checkmark icon. Let's add it. Taking elements in an array tells UNICE to put them in a line. Simple enumeration says to put an element on its own line. We can check. Nothing happens. Let's add a changed handler. And now, switching the element causes an info window with the switch value. Let's look at the range element. It is assigned to edit the numbers with minimum, maximum, and step. Let's copy it. And add it to our block. Changed is not defined. Let's change the handler. Write it here. Because we have it. So, it is correct. We have tied the handler. And now the system receives messages when the range element is changed. We see how it works. And we can drag it like this. As you like. So, we have figured it out. Let's look at the select element, which allows us to choose from the list one of the values. It looks like this. Its constructor, as well as all others. Name, value, handler, options. A handler can be absent, as usual. Let's copy the code and look closer. Switch to the screen. We have 3 selects. They are of different types. Let's add a new block to our screen blocks. We have 3 different types of selects here. The first is a radio. The second is a selection. The third is a list. The type is optional. UNICE can choose the optimal type for us. Add the same changed handler and look the same effects. Copy DataPy to the project folder. It contains data for our elements. And some data structures that we need in the work. What we have in this file. Take a look. Data contains remote image address, tree options, in which each tree element is referred to its parent. And for the graph, nodes, edges for tables, rows, headers, and Panda table. Let's add a screen to our screen folder. Add a screen. Call it second. Go to the screens folder. Write name equals name second and import from Unicy. Import I'll write a block. Block 1 equals block and connect it to blocks. Blocks equals block 1. We need to say that blocks are invented not only for beauty, but for separation and reusing functionality. Some blocks can be shared between screens, and they keep their state when we use them in different screens. So we make screen parts that we can use and organize in screens in different visual and functional ways. Not only in this project, they can be projected to other Unicy systems. Added an image there. Let's see what an image is. So, an image has a URL or file path instead of a name. It can also have a select handler. It can be selected. Let's import data variables. Import all and write an image to the block. Just write the image. Remote image. This is the variable from DataPy. We just took its value. What do we see? The image is directly behind the name. Let's put it under the name. The space right the name needs to be filled with an empty space. Empty array. Let's say the image is too big. Make it smaller. We've reduced it. Let's create a tree. A tree in the same block. Let's print a comma here. And create a tree. Let's see the constructor tree. So, the name, the value, changed handler, and the options. The same options that we had here. Each tree item is linked to a parent item. All root items have none value in the options dictionary. If the value is not none, it is a child item. Let's define tree element. Nothing is selected in the tree. Let's copy the changed copy for using it with new elements. Assign the handler to the tree. and assign tree options from data. Options equal 3 options. We have a tree. We added handler, so when we choose a tree item, we get info about a new selection. The system is notified that the value is changed. We can write any action we want. It will work like this. Let's add this change handler to the image and see what happens. In image constructor as usual. Path, value, a changed handler. We type false, and also type changed handler. Element value is true. Element value is false. We can select images. It is useful when we have a list of images. We can also have a list of images in blocks. We can list a lot of images, and the block will scroll them and show them with those sizes inside. What we will define them. Let's add a table now, or few tables. The table represent 2D data. Let's see the table's function. So, first, let's create a table block. Tablock equals block. Table block. And define a table here. Insert a table here. Insert an empty array in the block. To put it under the name of the block, set the name and see the documentation about a table. Name, value, changed handler. Value is what is selected in the table, and from the options we must specify rows and headers. Headers are call names, and rows are the table lines. Let's take from data. Headers and rows. Here are the headers, and rows is an array of arrays. Rows is array of table lines, and each line is an array of cells. Rows equals rows. Headers equals headers. And add it to the blocks. So, we can see that we have a table. We can edit this table. Let's edit something. Here, for example. We can also add or delete lines. Let's delete this line. Here we deleted it. It was also deleted in our table element. This deleted line is deleted also in the table rows. Here too. We can select, deselect multi-mode to select several lines at the same time. and immediately delete them, or do something with them. We can select them, and when selection is changed, the changed event comes to the system. Let's attach the handler here and see what I'm talking about. Right, the initial selection is none, and changed handler. Now we see that when we select, we have a table value of 6. This means that the 6th line is selected in the table. 15th. 0. Let's see what happens with multimode. We have an array. It is selected as 0 and 5th. 0, 5, 15. Now we will remove the selection and see that we have nothing selected. Let's add a panda table here, and we will put it under this table. The panda table is defined here. It is already there. We read it from the CSV file, and all we need to do is write such an announcement. Let's put a comma here and write a table here. Panda table. And here we will write the definition of the panda. Panda equals panda table. As we can see, it is filled with lines from the panda table. And if we start editing this table here, we will edit the panda table that we have transferred here, which is very convenient in some cases, because pandas are used in many places. Let's consider the chart element. Chart is based on table data and can be created by defining rows projection. If view table variable is defined, the table can be a chart. We have an example that tells us take the indexes of the lines as x-axis. And take the values from the first column and the second column for the y-axis. And according to this table, we get such a chart. Let's do the same with our data. We have a table, and in the data, we have a projection view. For adding a chart, just define the view argument. That is, we assign the chart projection. We see a chart button and can draw a chart. This is our chart. And we can select points here. When selected, the table handler works as well. Although we select points on the chart, not the table rows. The same handler works here. If switch back to the table, the same rows are selected in the table. And when we go back to the table, we will also have index 6 here. 0, 1, 2. Sync 3 was deleted, as you remember. Therefore, we have index 6 here. This is how the table projection works. In the chart, we can scale and scroll data. And, accordingly, select. Let's consider the param block. This is a block which creates elements for the program parameters. Just past there, a dictionary with variable names and values. And Unici will build a block automatically, just analyzing the values of these elements. Let's copy the block code. Let's make a new screen. Create a file third.py. Call it complex. And import it. Import Unici. And make a block. Format it a little. To see variables. So we see them. Let's draw this block. For that, connect it to the screen blocks. And here it is. Let's check how it works. To do this, let's make a handler for it. And a button for attaching the handler. Paramblock also improves variable names for us to have a more representative look. Let's copy the changed handler to the third screen. Normally we have to write it in a shared file like DataPy, and use it without copying. We never use the button value. It is always none. Modify the handler a bit. Define button handler. Button and value are as usual. And ask for the paramblock variables. Just return info about them. Convert to string. It is optional. And choose the params property, which returns a dictionary with actual values. So, we have params property in paramblock. And we can always get the current state of the block in any handler or custom code. So, when a user changes some values, Unici updates their values in paramblock. Should show 18. Let's check. Connect the handler to the button. Button handler. And everything should work. Let's make here a 19. Here set false. And check 19 is in the block. Load best is false as expected. So, make and attach a paramblock. And Unici automatically synchronizes the screen with internal variables. And we can always read their actual state. Let's add a graph on the screen. Make another block. Graph. Block. and right here. Graph. Name. G. Block. And take parameters for it. Let's write. Graph should have the name. Node. S. Edges. Look at the documentation. Name, value, handler as usual. Graph selection. And nodes and edges. Let's do it this way. We have a handler. The value should be graph default value, because value contains nodes and edges keys in the correct way, and assign nodes to the graph and edges. To make it work, have to import all from data. Check in data. Nodes and edges. Variables are already in use. It's nonsense in terminal. But it happens with Visual Studio Code sometimes. So we can see the graph is appeared, but we can see inefficient space using. For fixing the issue, we can put a block on another block. Declare one vertical area. For doing that, just put it in the array. Inside the blocks list, we enumerate vertical zones, which can be combined from several blocks. Let's add this handler to the graph. Then we will see its reaction on screen. Messages about the graph selection. Add the change handler. And check. The same handler works for the graph. Let's select edge. Here we have the edge, but not the nodes. We can select the edge and nodes. When press the Shift key, it is multi-select mode. The windows shows selected nodes and edges indexes. Let's select another node. 2 nodes and an edge. These are their indexes in nodes and edges arrays. How to modify a graph. Let's make here a button and code for modifying this graph. Let's see how to do it. Let's write def add node element and value. As usual, button value arguments. Value for button is always none. We have to refer to the graph. Declare the graph outside the block to get reference to it. Graph equals the graph. Now can process our graph in handlers attached to the other elements. Write code for adding node. First calculate the index a new node in the graph. The index equals the length of the node array. Then add a node. Graph. Nodes. Push. Not push. Append. A dictionary. Except the label, we can define the node size and color. The label is just an index. And add an edge. In Graph Edges, append. The Edge Dictionary can contain optional label and color keys. Source and target are mandatory keys. Copy and paste. The source is a new index. Target is 1. Let it be 1. And label is new. And we have to return the updated graph. For updating the graph for user, let's insert here button in this block, which is attached to Add Node Handler. The name is Add Node and Add Node Handler. Add Node button appeared at the bottom left corner. Move it to the block top. We have a button. It has to add a node with edge and return a new graph configuration. It works. Adds as expected. Let's now consider a new important block. Toolbar. It is a screen variable for putting elements in the toolbar. Let's test it. Just write toolbar equals an array of elements. Let's copy the button to the toolbar. Here it is, but the Add Node Handler is declared after using it. Fix it. The button is added. Let's turn it into an icon button, as it is customary in toolbar. To do this, we must hide its name. This is done by inserting underscore in front of the name. And define an icon. Icon equals added. There should be such an icon. And now we can add nodes to our graph. The same handler and action. Let's look at the dialog documentation. Uneasy supports modal blocks. In short dialog, dialog is formed as a block, but it has a callback for its command buttons. The handler takes the dialog and the name of the push command button and reacts appropriately. Let's look at the Uneasy services. Services. Autoconfig. The table shows how the system is configured. If such variables are omitted in the config file. Autologging. Auto means that the logging system is already fully operating in the system. All you need is to specify the logging file name. If we want to write something there, we need such a function. I've already looked at the automatic web GUI. Autotests. It allows you to create automatic integral tests for the entire system functionality. Write the autotest. We do the actions we need. Then stop. And Unici saves this test. And when the system is restarted, Autotest will check the equality of the test interactions. That is, Autotest reproduces user events and check for any deviations and reports exactly these deviations are if detects. Multi-user support. Our system automatically supports the environment for each user. And we can access user instances on any screen just by using the user variable. Unici adds the user variable to screens and blocks. REST is not needed in most cases. But if you need it, write IETPP handlers and point them at the Unici start function. REST for Unici is redundant because we have the unified remote API, which is much better, much smarter, faster, and ready to use. Just remember several functions. Just insert it where you need to use it. AutoCheck scheme. It automatically checks all screens and blocks declarations. We receive assurance that all screens have correct descriptions before using the system. This is a very useful shared session. Let's have a look. This is an interesting service. For activation, write in config. Mirror equals true. And restart the system. If we change config, then have to restart the server. So we started a shared session. Let's enter as a second user. And see what will happen. What will we have? We can see that the user interactions cause the same changes for another user. If switched to another screen, then another user does not see these changes, because only the same screens are synchronized. If switched to the second screen, then automatically, the screen blocks are wider the screen area. We will see the same effect. We figured it out. This is needed for joint work, teaching, presenting, or for cheap and fast interaction of unified remote API. When one session is enough, we do not need to make a separated session for each user. In short, for increasing performance, here is contact information. Forgot to write our site name. Unici Tech can visit and read our roadmap. Here will be the most recent information. If you face errors or issues, then use the GitHub Issues board. Consulting and technical assistance is accessible on the Unici site. Good luck. Bye.